Hi viewers, this is Sri Ramulu, degree lecturer in physics. YouTube channel is S.S Space Physics. So before watching this video, please like it, share it, and subscribe also. So my today's topic is a temperature entropy diagram, and this is also called as TS diagram. Why? Because why it is called as TS? Temperature denoted by T, entropy denoted by S, so that is why it is also called as TS diagram. That means how the changes occurs, how they are related, in graphically. So that is I will explain today in this class, in this session. Now a graph plotted in temperature and entropy is known as temperature entropy diagram. See here, just graph only. If we draw the graph in between the temperature and entropy, that is temperature entropy diagram or TS diagram. Consider a Carnot cycle working subs Carnot cycle, or the working substance undergoes the following operation. In Carnot cycle, we know there are the four processes. Every cycle undergoes four processes. One is isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. These two belongs to the expansion. These two belongs to the compression. Okay, friends, that is you must keep in mind. Isothermal expansion at a temperature T1 of source. So why? Because T1 is a source temperature, and at this temperature isothermal expansion takes place. Adiabatic expansion, where the temperature falls from T1 to T2. Only temperature decreases. Why? Because here, as the temperature decreases, it is like this. It shows temperature decreases. And generally what we call, this is called PV diagram. Why? Because pressure versus volume. How the pressure versus pressure and volume are changes. Okay, so that is what is called PV diagram. So by using this PV diagram, we have to draw the TS diagram. So temperature we have to take on y axis, and entropy we have to take on x axis, and we have to draw in four different process how the temperature and entropy changes. Okay, now adiabatic compression. Okay, see here, expansion, compression, just now I told you. So isothermal compression at a temperature T2, adiabatic compression such that temperature rises from T1 to T2. See here, this is takes place at constant temperature, and this is also takes place at a constant temperature, but this constant temperature is higher temperature, this is lower temperature. And in adiabatic, Q is constant but not temperature constant. Heat energy is constant. But temperature in adiabatic expansion, temperature falls from T1 to T2. But in adiabatic compression, temperature rises from T2 to T1. Why? Because it is higher temperature. Here high to low, here low to high. So that is these things you must keep in mind while drawing the TS diagram by using PV diagram. Okay, friends. Now, these operations are shown on PV diagram. The corresponding TS diagram is also shown in figure. So it is a PV diagram, it is TS diagram. The explanation of TS diagram is as follows. We know that entropy, we know that entropy changes linearly in isothermal process while it remains constant in adiabatic process. Here he is explaining about the entropy only. So entropy linearly changes in isothermal process. That means linearly changes means as at constant temperature entropy increases. Here linearly means, so if one quantity increases, other quantity also increases. That is a linearity, while it remains constant in adiabatic. So that means it changes with. Okay, so we know that entropy changes linearly means it sometimes increases and sometimes decreases. That is the linearity. Okay, not exponentially. isothermal process while it remains constant in adiabatic process. So in adiabatic process no changes will occurs. Okay, only changes occurs in isothermal process only. Why? Because there are the two different types of isothermal process are there. One is isothermal expansion, it is given here. Another one is isothermal compression. But in adiabatic process also we have the two things, adiabatic expansion and adiabatic compression. But in these two cases entropy do not changes, but in these two cases entropy changes will occurs. But in isothermal expansion entropy increases, and in isothermal compression entropy decreases. So already I explained these things in the previous video, please watch that. That is a change in entropy in reversible and irreversible process I explain you. As shown in the figure, during the isothermal expansion AB. So see here, there is this one, isothermal expansion AB at constant temperature. Here isothermal process takes place at constant temperature only. Adiabatic process takes place at constant heat. As shown in figure, during the isothermal expansion AB at constant temperature T1, entropy of working substance increases from S1 to S2. So now see the diagram, TS diagram. In the TS diagram, what is it? Is a isothermal process, adiabatic process. Isothermal, it is a isothermal, it is expansion, it is also expansion, compression, and it is a compression. Okay, so in this process, so see here in A to B, while we are moving from A to B, in this process entropy increases. So entropy is increasing. Entropy increasing means the temperature remains constant in isothermal process. And next, as shown in the figure, during the isothermal expansion AB at constant temperature T1, entropy of working substance increases from S1 to S2. Suppose it is increasing from here to here, means let at this point it is a S1 and at this point it is S2. So it is increasing from S1 to S2. During the adiabatic expansion BC, adiabatic expansion, it is a BC. For this BC, entropy remains constant but temperature falls down. Okay, so here entropy remains constant, temperature falls from T1 to T2 here. So T1 to T2. So for it is falling means like this, in this direction we have to come. So while we are moving in this direction from B to C, entropy do not change but temperature changes. Temperature changes means temperature decreases. From where to where? From T1 to T2. So this is a adiabatic process, adiabatic expansion. It is isothermal expansion. Next, one more thing is that during the isothermal compression CD, it is isothermal compression CD. Where is the CD? Is from here to here, C to D. In C to D here, what is happening here? C to D, it is related to the what? Isothermal compression. So these two are the same things. So how these two are related, and these two are related, and these two are also related like this. Okay, so it is isothermal compression, and this is also isothermal compression. In isothermal compression, see compression, what is taking, it is taking place at constant temperature. Temperature constant means that it should not change. But what happens? Entropy decreases. Entropy decreases where to where? From S2 to S1. Like this, entropy decreases. So here entropy increased from A to B, entropy increased. From C to D, entropy decreases. And here during the isothermal compression CD at a temperature T2, entropy decreases from S2 to S1. Right? Reverse. Here from here to here, S2 to S1. And next one, finally, it is a final one. Finally, during the adiabatic compression DA, where is the DA? D to A means from here to here. So that is also shown here in this TS diagram. D to A here. This is the TS D to A. Entropy remains constant while the temperature rises from T2 to T. Here entropy same constant. Here no change in entropy like this. So if you move either upward direction or downward direction, entropy do not change, but the change in occurs way in temperatures only. Here we are moving from D to A, means the temperature has to rise from T1 to T2. Okay, so like this, this is the TS diagram explanation. And next, area we have to calculate how the area depends upon the TS diagram, and how does it converted into work. In this way, TS diagram is a rectangle The area of cycle of TS diagram gives the available thermal energy for useful work in reversible process. Okay, just now I told you its area gives us how much available energy will occurs. Okay, as the area is more, available energy is also more, then it is very much useful for doing work. Okay, so next, let S1 and S2 be the entropies at A and B respectively. In the isothermal change AB, the entropy changes from S1 to S2. It is isothermal expansion only. In isothermal expansion, what happens? The entropy changes from S1 to S2. S1 to S2. That means entropy increases. Hence, increase in entropy given by S2 minus S1. It is a change in entropy. How much entropy increased we can calculate by subtracting S2 minus S1. See the diagram. So it is S2. It is S2. It is S1. So we know S2 is more than greater than the S1. And if you take the difference, then you can get the, how much more entropy increased. Let Q1 be the amount of heat absorbed by the working substance in isothermal expansion. So in expansion, only heat energy will be absorbed. That heat energy can be shown by Q1 only. And Q2 be the heat rejected in isothermal compression. CD. So in isothermal expansion, heat energy will be absorbed, that is denoted by Q1. But in compression, heat energy rejected to the sink, that is denoted by Q2. So that is why, according to entropy, second law of thermodynamics. So second law of thermodynamics, what? dq is equals to TdS. It is the second law of thermodynamics relation. So dq is what? For I'm speaking about the isothermal expansion. In isothermal expansion, what happens? It is a relations of isothermal expansion. In isothermal expansion, heat energy is equals to temperature into change in entropy we need. So heat energy I have taken Q1. Why? Because isothermal expansion. And isothermal expansion, temperature of source is T1. So in the place of T, I have substituted T1. And in the place of DS, change in entropy. Change in entropy is S2 minus S1. Okay. So Q1 is equals to T1 into S2 minus S1. Okay, so like this, it is for only isothermal process expansion only. Okay, so and here AF, how we got AF here? So now if you want to know the AF, we have to move to the graph and observe the graph. See the graph. This is the graph. And what I have written there, in the place of T1, in the place of T1 I have written AF. T1 AF, wait to wait. T1 means from here to here it is T1. Okay, so it is A and this is F. I have written here, I have labeled this diagram as A B C D and E F, these 2 points EF. So AF means here to here. T1, it is total, what it is from here to here is, it is T1 value. This one T2 value, this is, but we don't need T1 here to here means that is simply AF it gives. So that is why I have written here AF. Okay, AF like this. And what is the S2 minus S1 as a B AB? S2 S1 minus S1. Okay, S2 means this is a value. S1 means this one. So that means from here to here. Here to here is what? It is simply AB. Why I'm not taking CD? CD is also same thing na? From C to D. But I am not taking CD. I am taking only AB. Why? Because I am speaking isothermal expansion only. Isothermal expansion this is. And CD gives isothermal compression. I am not speaking about the compression. I am speaking about the expansion. So that is why I am taking AB instead of CD. Okay, AB is what? S1 to S2. S star S2 to S1. So that is why here AB is written. Okay, so it is AB. And see AF and AB. AF and AB. Once again, let me draw here only diagram. No need to move there. And this point is A point, and it is B. It is B, C, D, and just below it I have written here it is E, and this is F, and it is S1 for place and S2 place. Okay, please. Now, and now see here, AF. AF means what? This is AF. A to F here, this point, here to here point. And next point is what? AB. AB is what? This one. Okay. So I said you in the beginning it is rectangle. AB is a length and AF is a breadth. Length into breadth is what? Here length into breadth gives area. Area of what? Area of, it is also from here to here means area of ABEF only, not C, ABCD. ABEF area only. Why? Because A to F and A to B. So that means this total value we have to take. And next similarly Q2. So it is a isothermal compression. It is for isothermal compression. It is isothermal expansion. It is isothermal compression. And dq is equals to same formula. This formula I am implementing here. I am using this formula only. Heat energy is equals to temperature into change in entropy. So heat energy is taking heat energy q2 y in sync in isothermal compression. Isothermal compression heat energy is q2. Q2 heat energy, and its temperature is what? Its temperature is T2, lower temperature, sink temperature. And same thing, ds means change in entropy. Okay, and in the place of q2 same thing is written, but in the place of t2 df is written, t2. So according to diagram, so see here once again diagram, it is what a, and this is the b plus c, and it is the d, and just below it, here to here, it is e, and this is f, here s2, and this is s1, and it is at a temperature T1 from here to here. But from here to here, it is temperature T2 only. Okay, now see, T2 means T2 temperature. Where to where? From here to here. Here is what? It is a D, and this is F, DF. So that is why DF is written. Okay, and next to S2 minus S1. S2 minus S1 is CD we have to take here. Why I am not taking AB? AB is isothermal expansion, it is belongs to. It is CD isothermal compression. So it is belong to the isothermal compression. So that is why I am taking CD only. So CD or DC. It is a breadth and it is a length. Here breadth into length gives area. So breadth into length gives area. Area from this area only it gives. This area. So this area is what? It is CD, EF, CDEF or DCEF, DCEF. So this area, okay, DC. Q2 is the belongs to this area, and Q1 is belongs to the whole, not only this one, and also includes this one. Q1 is belongs to whole. But what I need only this area. I need only this area. Why? Because this area is belongs to the TS diagram. Okay, I don't need this one. Then what I'm doing, I'm subtracting this value from this total, from this total, what I'm doing, I'm subtracting this one, then I can get this one. Okay, so for this total means q1, and this value means belongs to q2. So q1 minus q2 if you do, then we can get answer, right? So thus the area of TS diagram, once again here diagram is given. Okay, so just for understanding only, no need to write in the examination twice. As you wish, if you have capacity to write, then you can write. All right, so thus area of cycle on TS diagram gives the available thermal energy that can be converted into useful work. So efficiency calculated, efficiency formula is what? See here, eta is equals to q1 minus q2 by q1. It is already, we know the well known formula of a Carnot heat engine. Q1 is the area of ABEF. So above just it is given. Q1 value is this one. And area of DCF, it is Q2 value. It is Q2 value. Next by, what is that? What is we have here? Q1 we have. So by Q1 formula. Okay. So what is here? See once again. So it gives area. This area minus this area. This area is what? It is a whole area. This total area is Q1. And this is what? This small area. But what I need, it is a shaded area I need. Then if you subtract this whole value, okay, it's from this whole value, if you subtract the small value, then we can get this one. This whole value belongs to the q1 and the small values belongs to the q2. Then after difference we can get this one, that is abcd. Okay, that is area abcd. So like this we got area abcd. Area of abef minus area of dcef is equal to area of abcd. By it is as it is, no change. And again let me write it is in terms of length and breadth only. abcd. So let it is ab is a breadth and this is a length. Okay, or it is a length, it is a breadth, as you wish. Okay, so it is a ad ab. So abcd can be written as ab ad. Similarly abef, where is abef? ab ef, ef means this one. So that means let it is a breadth and it is a whole width. So ab af, ab af. Now ab ab gets cancelled, ad by af, ad by af gives the efficiency from this diagram. Why? Ad is what? Ad, see here, ad, ad where to where, from here to here, it is ad. How can we get this value ad? So here to here is t1 and this is a t2. So if you want this one only, then t1 minus t2 gives this one only. So t1 minus t2 by af, af where to where, here to here af, here to here af means it is here to here t1. So t1 minus t2 by t1. So like this, so we can get efficiency from this ts diagram. So this efficiency, so like this, the ratio of ad by af on ts diagram gives efficiency. Okay, on pv diagram also it gives efficiency, and also ts diagram it gives efficiency. Okay friends, thank you for this watching this video till